All right, welcome back. First things first, we want to make sure that you have something to write with and something to write on. We want to write down any questions that we have. We want to take notes that we can refer back to. So please make sure that you have something to write with and something to write on always. And we're going to get started. So you might remember from our last lesson, we defined 4 terms. We defined categorical data. And this is the data set that where the answers are categories. An example would be different breeds of dogs. A non-statistical question we defined as a question that has one succinct answer, right? So there's no variability in the answer. For example, how tall is Mr. Doherty? Numerical data. Numerical data is data where the answer is a number, okay? So how many desks are in a room? Numerical data. And finally, statistical question. A statistical question is a question with an answer with variability, right? So what is the average height of everybody in Mr. Doherty's room? Statistical question. All right, so hopefully you remember that from last time. We're gonna take a look at the question that we had. So we had 4 different questions, and you were asked to categorize each of these questions into different types: statistical, non-statistical, categorical, numerical. All right, so what I want to do is I want to give you a couple minutes. I want you to try to match these up again. So we will reconvene at 3:30 and go over this. I'll give you a 30-second warning. All right, 30-second warning. All right. So the first question says, how many acts are in the play Romeo and Juliet? All right, so how many acts, that's a numerical question, right? Because we're looking for a number. And it is a non-statistical question because it's got only one answer, right? There are only so many acts in the play. On average, how many books does each person in the United States read each year? This is a numerical question. And this is a statistical question, right? Because you may read more books than I do, or I may read more books than you do, right? So there's going to be variability to that. Which book was read most by students in the class this summer? This is going to be a categorical question, right? Because the books are a category and not a number. And it's going to be it's going to be a statistical question because there's going to be variability. There are going to be different books than everybody read this summer. Finally, how many books are in the classroom right now? How many books is going to be a numerical answer. And in the classroom right now, that's going to be a non-statistical question because there's only going to be one answer to that question. All right, so let's go through the answers and let's match them up. Maybe we'll change the color here to red. All right, so statistical question requiring categorical data. Statistical categorical, that's this one right here. Books read by students most this summer. Statistical question requiring numeric data, right? Statistic numerical, That's this one right here. How many books does each person in the United States read each year? The last two, non-statistical question. They're both non-statistical questions, right? And so that would be both of those. They're both the same answer, okay? So hopefully that is what you got. We're gonna take another step in this next lesson, and so I'm excited to get started. Algebra 1, Unit 1, Lesson 2, Data Representations. Our learning goals today: let's represent and analyze data using dot plots, histograms, and box plots. Our learning targets. So by the end of this lesson, you should be able to find the 5-number summary for data, and you should be able to use a dot plot, histogram, or box plot to represent data. All right. So notice and wonder, battery life. So if you haven't done a notice and wonder activity before, here's what it entails, right? So when you're noticing something, you're looking at it and you're making an observation that you think is important about it. Okay, so that's what a notice is. A wonder is just a question, right? So based on these things that I think are important about the things I'm looking at, in our case, they're going to be different statistical representations. These are the questions that I have about it, right? So what I'm asking you to do is come up with a couple of things that you notice that you think that are important about these, and then a couple of things that you wonder. And let me explain the situation. So the dot plot, this is a dot plot right here, the histogram, and the box plot summarize the hours of battery life for 26 cell phones constantly streaming video. So what do you notice? So what do you notice that you think is important about these representations, and what do you wonder? Remember that these are all representations of the same data. What I'm going to do is I'm going to give you a couple minutes to come up with some answers, and then we'll talk about it. So we'll reconvene it at 8:45. Give you 30-second warning. All right, 30-second warning. All right, so there's going to be a lot of variation about what everybody noticed and what questions you had about these, but a couple of things that I noticed. In the dot plot, I noticed that the most frequent battery life was about 5.5 hours, right? So right in the middle of 5 and 6. I also noticed that the minimum here I see the minimum here 2.5, and I see 2.5 right here. That's not a lot of battery life for a phone, so I think I would be very dissatisfied if my battery life was 2.5 hours. And then the other thing that I noticed that I thought was kind of interesting is that the box plot down here has a line of symmetry. So it looks like, if you remember from 8th grade, right, a line of symmetry separates a left side from a right side like a mirror image. It looks to me like this data is the same as this data, but I can tell, but because these all represent the same data set, I can tell from both the dot plot and from the histogram that this data is not a symmetrical image of one another. So I thought that was interesting as well. And I'm sure that you found some interesting stuff too, and I look forward to reading it. All right, let's go on to the next question. So of these three representations, which one of these shows all of the data values. So take a look at this. I'll give you about 30 seconds to do this, and it should get immediate feedback when you put it in Desmos. Okay? All right, and that is the dot plot. So the dot plot is the only one of the three of these that show all of the data values. Here, the box plot separates them into quarters, right? So you got 25%, 25%, 25%, 25%. Here, the histogram represents, it puts them into segments, right? And so this segment is all of the values between 2 and 3. This segment is all of the values between 3 and 4, all right? And so these do not give you the individual values as well. Only the dot plot does. All right, so next question I want you to do, I want you to conjecture. So kind of imagine, how do you create a box plot, right? So again, we're taking a look at this box plot right here. Let me blow it up for you. Can I do that? All right, there we go. And there we go. How do I make a box plot? Let me give you about 90 seconds. I want you to try to explain to me, how do you make a box plot? So we'll reconvene at 13 minutes. All right, 30 seconds. Okay, so once again, the information that the box plot gives us is to break it down into quarters, right? So each segment represents 25% of our data. And so we've got, so this left tick represents the minimum, the right tick represents the maximum, the median is the exact middle. Another way of saying middle is median. And then the median of the median and the min, so on the left-hand side, breaks it into the first quarter, what we call quartile 1. The median between the median and the maximum breaks it down into quartile 3. And we'll have an exercise where we go into it a little bit more, but hopefully you were somewhere around, hopefully you had something like that. All right, so next activity we're gonna do is to create a histogram, right? So a histogram can be used to represent the distribution of numerical data. The data here, so this is, you've got 30 values here, represent the number of days it takes for different tomato plants to produce tomatoes. You're going to use the information in the data set to create or to complete the frequency table. And I'll show you how this works. So here I've got a value of 47. All right, what I'm going to do is I'm going to put a tick mark here in 40 to 50. Right? And then here I've got a value of 52. I'm going to put a tick mark here, 50 to 60. All right, and so what I'm doing is I'm counting how many values fall between 50 and 60, right? And this is giving me my frequency table. And if you think about this from the histogram that you see below, what I'm really doing is I'm finding out, so I've got these intervals. What I'm doing is I'm figuring out how many numbers in each one of the intervals. One thing I want to point out to you, here where I've got a value of 60, right, I've got a 60 and 50 to 60, and I've got a 60 and 60 to 70, so right on the precipice of both. in this instance, you will round up. All right, so 60 will go in the 60 to 70 interval rather than the 50 and 60, and that's just kind of a convention that we have. All right, so what I want to do is I want to give you 4 minutes to try to populate this frequency table. So you got 30 values. You should have a set of numbers in 4 minutes. So we're going to reconvene at 19:15. Right, 19:15. I'll give you a 30-second warning. All right, 30-second warning. Okay, so the next thing that we're going to want you to do is take this information that you've put into the frequency table, and you are going to bring it down and create bars in your histogram, right, in the intervals that we set up. So there's no data in here for 30 to 40, but just take, for example, say that there were 3 values that fell between 30 and 40. I would put a line here for 3 and make a bar here, and that would be the first bar of my histogram. All right, and so all you have to do is take this information that you just put in the frequency table, and you just put that into the histogram, right? So all of these different values. I'm going to give you 2 minutes to do that. So right now, so 20 21:45. 21:45, I'll give you a 30-second warning. All right, 30-second warning. Okay. So what we're going to do in this next one is, okay, so I'm giving you a new frequency table. It's the same data that we had, but now we're putting it into intervals, 40 to 45. So 5-unit intervals instead of 10. What I want you to do is I want you to take the new frequency table that I gave you, and I want you to create a new histogram from this data. And we just want to see what the shape of that looks like, right? So for instance, 30 to 35, if there were 6 values, then we would put it up here. You're just going to take the information I give you in the frequency table and you're going to create a histogram from it. And because there are extra ones, why don't I give you 2.5 minutes? We'll reconvene at 25. Give you a 30-second warning. All right, 30-second warning. Okay? Oh. Sorry. Okay. So now really quickly, just want you to compare the two histograms that you created. How does this histogram differ from the other one? How does your second one differ from the first one? All right, so let's just do 60 seconds. Want a quick write, just kind of compare the second histogram, the first one, reconvene 25:30. Or sorry, 26:30. All right, 30-second warning. All right. Okay, so really quickly, where did you put the 60? Did you put it, and this is for the first one, you put it in the 50 to 60 interval or 60 to 70 interval? Let's see if you remember what we talked about. All right, give you 30 seconds. 27. All right. So you should have said that you put in a 60 to 70 interval. Remember, that's just a convention that we have. If we have something that's on the precipice of a lower and an upper interval, we put it in the upper interval. All right. What information is easily seen with a histogram? All right, so let's just do another quick write for a minute. Reconvene 28:15. What information is easily seen in a histogram? Thirty seconds. Okay. So the next question I'm going to give you 90 seconds for because I really want you to take a look at both these histograms and I want you to analyze it, okay? So according to each one, so do this for both histogram 1 and histogram 2, what appears to be the typical number of days it takes a tomato plant to produce tomatoes? So typical would mean like a mean or a median, okay? So what appears to be the typical number of days it takes a tomato plant to produce tomatoes? Yeah, why don't I give you until 30, okay? Give you a 30-second warning. All right, 30-second warning. Okay, so the reason I ask you to analyze both of these is that, if you take a look at histogram 1, right, it looks like the mean or the median is probably right here at 70, right? But if you take a look at 2, the most frequent value is probably right here between 75 and 80, so maybe 77. So you can see how by decreasing that interval, you get more granular and you maybe get a more specific answer than you might have had otherwise, all right? Which leads us to the next question, and let me give you a quick minute, so we'll do a quick write. What information is not seen in the histogram, right? And think back to the dot plot and what the dot plot can give you and what a box plot can give you relative to a histogram, okay? So quick minute, 31:40. We'll reconvene. All right, 20-second warning. Okay, so hopefully you came up with some ideas. Most prominent to me is that you can't see the individual values here, right? So you're seeing things in intervals that you're not seeing but you're not seeing the individual values like you could in a dot plot. So there's some advantages to histograms, but one of the biggest disadvantages is just that you can't see the actual data. All right, box plots. All right, so a box plot can also be used to represent the distribution of numerical data. Using the same data as the previous activity, right? So right here, right? Find the median. Another word for median would be middle, and add it to the table, right? So we're going to add a value right here. So you've got 30 values, right? So the median should be in between 15 and 16. All right. So let me give you about 90 seconds to come up with the median and put it in your table. Okay. So we'll reconvene at 34. All right, 30-second warning. Okay, and the median here falls between, so the 15th number is 70, the 16th number is 72, so the exact middle of this data set is going to be right in between 70 and 72, and the number in between 70 and 72 is 71, okay? So that would represent the median for this data. All right, the next question asks you to find the median of the lowest 15. So here are the lowest 15 values, all right? So now we want you to find the middle number for the smallest 15 values, all right? So why don't you take about a minute and 10 seconds. So we'll reconvene at 36 and we'll find Q1. All right, 30-second warning. Okay, so the number right in the middle of the smallest set is going to be 62. So there are 7 numbers to the left, there are 7 numbers to the right, and so what we call quartile 1, right, the median of that left-hand side, quartile 1, which separates the data into the first quarter and the second quarter, is 62. And so the next thing I want you to do is I want you to do the same thing for quartile 3, which would be, or for the largest set, right? Find the median of this largest 15. Go ahead and do that. I'm going to give you a minute to do that. That should be pretty easy for you right after doing the last one. So we'll reconvene at 37:40. All right, 30-second warning. All right, so 7 values to the left and 7 values to the right. The absolute middle of the top is 78. Okay, 78. All right, next we want you to add the minimum, right, the smallest value right here, and the maximum value right here. So take a minute. So we'll do 38:45 to have both of those values in there as well. Go for it. All right, 30-second warning. Okay. All right, so the minimum value, right, the smallest value here is 47, and the largest value here is 90. And you, ladies and gentlemen, have just completed a 5-number summary. And the next question asks, can you create a box plot from this data? All right, so let's try to create a box plot from this data. There is a, let's see, there's a demonstration to help you. There you go. So create a box plot using the 5-number summary. I give you one more minute, so 40:30. Thirty seconds. Okay. All right, so the median here, the middle line is 71. The minimum line is 47. The maximum line is 90. I've got quartile 3 here at 78. I've got quartile 1 at 62. And then I'm going to put the single line here, make the box what's going to be known as the interquartile range. We'll learn about that, and it should look something like that. All right, quick write. Let me get, how about 30 seconds? What information is easily seen in a box plot? 4135, go. Okay. All right, and according to the box plot, what is the typical number of days it takes a tomato plant to produce fruit? And remember again, typical would be mean or median. So let me give you about 20 seconds to come up with an answer there. All right, so 4205. All right, and the median, remember the median here is right there, right? At about 71, 72, okay? All right, what are the strengths of each representation, right? So one strength for each one of these representations, I'll give you a minute. We'll reconvene 4315. One strength, one positive thing about each one of these representations. All right, 30 seconds. Okay. All right, so a dot plot lets you see all of the data and how it's distributed. The histogram summarizes the data into intervals that make for fewer columns, and the box plot displays the 5-number summary graphically. So let me give you another 20 seconds to fill in any blanks you got. So 4345. Okay, what are the weaknesses of each of the representations? Let's quick write for about 30 seconds. Go. 4420. Okay, and a dot plot has many columns of dots that can make it difficult to determine patterns. The histogram and the box plot don't display individual data in the data set. I'll give you about 20 seconds to fill in any blanks you got, and we'll reconvene at 45. Okay. All right. And how do you find the typical value for a data set? So again, typical we talk about in terms of mean and median. Mean and median. How do I find the typical value of a data set? Give you about 30 seconds to conjecture about that. 4540. Okay? So you can calculate the mean or average or median or estimate the mean or median using a graphic representation. So let me give you another 30 seconds to fill in the blanks. So 45, 15. And we got one more problem, we're done, folks. Okay, cool down. So the dot plot, histogram, and box plot represent the distribution of the same data in three different ways. What information can be most easily seen in the dot plot? And then the second question, what information can be seen most easily in the histogram? And the third question, what information can be seen most easily in the box plot? And once you finish those questions, you are done and ready to get on to your homework.